Hi, welcome to our final exam review for college algebra. So your exam will be made up of two parts. Part one is the multiple choice portion. Part two is an open response portion. This is a review to help you get through your multiple choice portion. Let's begin. So your first question is asking you to graph the quadratic. And it'll be multiple choice, so you have different options to choose from. Now, an important point of a parabola is the vertex. Finding the vertex tells us our key point. Also, knowing if our parabola opens up or down is hugely helpful because it doesn't start with a negative, it starts with positive. We know our parabola opens up. So, with that, it doesn't help us much. Let's go ahead and find our vertex. Now, our vertex, we can find it using the vertex formula, which is negative b over 2a. Get an answer, then plug it back into your equation to get the k. You can also try to put it in vertex form and then extract your vertex from there, but since it's not given in vertex form, vertex formula might be the best choice. All right, so if we go ahead and find the value for negative b over 2a, we get 2. We plug in 2 into our function, and our output is 0. So we get that our vertex is 2, 0, and there's only one graph that matches that and opens up, so we have our answer. 2. Use synthetic division to perform division. Synthetic division is a helpful way to get through a division type problem. Now remember, it's always x minus your c. It's also helpful if you just solve for it. So we're going to divide using negative 2. Now every degree in your polynomial needs to be represented. So I have x cubed, x squared, but I don't have an x. So make sure you add a 0 placeholder. All right, to perform synthetic division, you bring down your first number, and then you're going to multiply and add until you're done. So we multiply negative 2 and 1, we get negative 2. We add negative 1 and negative 2, we get 3. We multiply 2 and 3, we get positive 6. We add 0 and 6, we get 6. And your last number is always your remainder. Now we build up our polynomial with no variable, and a variable of 1 more degree. So this would be our answer. And we see that C is our solution that matches. Now be very careful, they all kind of look the same. For 3, give all possible rational zeros for the following polynomial. All right, so we want to go ahead and list possible rational zeros. And to do so, we're going to list all the factors of our last number divided by the factors of our first number. So the factors of 18, I can get 18 from 1 times 18, 2 times 9, 3 times 6, and that's about it. I can get 2 from 1 and 2, 1 times 2 only. Okay, now division of all of these is our answer. So 1 divided by 1 is 1, 2 divided by 2 is 2, and we see that by dividing by 1, we get all the numbers in the numerator in return. If I divide by 2, I get 1/2. 2 over 2 is 1, which we already have. Get 3 over 2, and 9 over 2 that are new. So these are our lists. You want to make sure you find one that matches. Don't forget the plus or minus for each number in our set. And C would be our answer. 4. Find the center and radius of the circle whose graph is shown. All right, so we see that we have a center of negative 3, 2, and we have a radius of, if we count the units, we have a radius of 2. If it's helpful, you can use your formula to come up with your answer. And we see that A is the matching result. So if it's helpful, what I mean by that is you can replace the H and the K from the center and replace the R and then plug them in to work it out. 5. If the function is 1 to 1, find its inverse. If not, write not 1 to 1. Okay, so to find the inverse, we have a process. Replace f of x with y, swap all of your x's and y's, and then solve for y. Okay, so I want to get y by itself, so let's go ahead and add 5 to both sides. I want to get rid of that cube root of that cube, so take the cube root on both sides, and we get y by itself. Our answer is the cube root of x plus 5. 6. Graph the rational function. This is a problem that has a lot of steps, right? We have to find the vertical asymptote, horizontal asymptote, x-intercept, y-intercepts. Let's begin with some key points, our vertical and horizontal asymptotes. Your vertical asymptote is always by the denominator equal to 0. Once we set our denominator equal to 0, we can go ahead and solve. We get a vertical line of x equals -4. For a horizontal asymptote, we're going to go ahead and look at our leading coefficients. Because they're of the same degree, we have a horizontal asymptote at 1. And it's easy enough that by process of elimination, we can find our correct answer. 7. Solve the equation. We spent a lot of time on this. When we have the variable in the exponent's place, we have to be a bit more careful and be a bit more tricky with our process. So we see that we have a base of 4 and of 2. Is there a way we can get those numbers the same using exponents? The answer is yes. We can make a base of 2 for both sides of our equation. So on the left-hand side, I have a 2, so that can stay the same. I have a 4. I can get it out of a fraction form by using a negative exponent. And lastly, you can get a 2 by replacing that 4 with a 2 squared. Remember, we have an exponent raised to an exponent, they multiply. Now that we have the same base, we can go ahead and ignore it and just go ahead and work with our exponents. We go ahead and solve for x. So we go ahead and try to get x by itself. So we subtract 7, 3x equals -9, divided by 3, divided by 3, x equals -3. Our answer is A. For 8, we solve the system using elimination. The idea is you want either both of your x's or both of your y's to cancel out. We can make, my initial idea was, well, we can make our x add to make 0 if I multiply it by a -7. So I did so and I multiplied -7 to each one of my first equation. I added them and my x's canceled. I got y equals 7. I plugged that into any one of my equations, and then we get y equals 6. Remember, your answer is always x comma y. For 9, write the equations one as a logarithm of a single expression. Assume that the variables represent positive numbers. All right, so I kind of tried color to guide you. So that first highlighted portion tells us log of a cubed minus log of a r. Because it's subtracting, we're going to divide the first divided by the second. And then we can use our exponent rule to change that 2 to an exponent. All right, from there, whenever we have two logs adding, we can multiply them to get this answer. Now we have them as a single expression using one logarithm. 10. We have a compound interest formula. The question reads, Austin invested $12,000 in an account at 12% compounded quarterly. Find the amount of Austin's account after a period of 5 years. So we have two formulas that we can use. And the main difference is the word continuous. Because we do not see the word continuously, this is our equation we have to use for compound interest. All right, so then we just fill out all these pieces, which we get from the equation above, from the word problem above. The one thing I would highly be careful of is when we're given 12%, remember to change it to decimal. We go ahead and plug them in and slowly use our calculator to get our final answer. All right, that's it for your review. I went through it quickly with the hopes that you'll make it a point to see it all. I figured a long video would make it kind of unappealing. But if you have any questions or if you need to see an example in more detail, stop by office hours or email me. Thank you.